All right, guys, I'm going to go over the answers to the homework from last night. All right, so we have a ball being thrown straight down from the top of a 220-foot building with initial velocity of negative 22 feet per second. All right, what is the position equation for the ball? All right, so our S of t, our position equation, is going to be, since it says feet per second, that means we're using the feet equation, so it's negative 16 t squared plus the initial velocity. The initial velocity has been negative 22 because we're throwing it down. So it's minus 22 t, and then plus the initial height, which is 220. And there's our answer. So there's our position equation for this problem. Okay. So now it says, what is the velocity at 3 seconds? So we need to figure out the velocity equation, which is the derivative of the position. So it's negative 32t minus 22. And then we're just going to plug 3 into that, which means we're going to put 3 in for t. All right. Just happened there. All right, there it is back. Sorry, I don't know what happened there. All right. All right, so we're going to plug 3 into that t. So when we do that in calculator, it should be negative 32 times 3 minus 22. And that answer is negative 118 feet per second. That's the velocity. All right, we would just plug 3 in for the t. All right. So this one's a little tricky, number 3. What is the velocity after falling 108 feet? All right, so what we need first, when you do velocity, you need to know a time. So we need to know at what time did it fall 108 feet. So let's think about this step. So we're going to use the position equation. All right, we're going to use negative 16 t squared minus 22t plus 220. However, we're not going to set it equal to 108 because it says after falling 108 feet. So if I had a 220-foot building and something fell 108 feet, what's the new height going to be? That new height is going to be 112 because 220 minus 108 is 112. So we're going to set the position equation equal to 112. And then we set this equal to 0. Negative 16t squared minus 22t. So 220 minus 112, that gives us 108. And this is the equation that we're going to plug into the calculator using menu 333. And we end up with t equals 2 seconds. All right. So t equals 2. So then we're going to take that 2 and we're going to plug it into the velocity equation because at 2 seconds, that's when it fell 108 feet. So to figure out the velocity, we then plug it in 2 into the velocity equation, which is negative 32 times 2 minus 22, which is negative 86. Right? And that is our answer for that one. All right. All right. So now we're on to the next problem where a ball is thrown straight out with initial velocity of 40 feet per second with initial height of 100 feet. Answer all the following parts. Okay. Position. Once again with feet. So that means it's going to be negative 16 t squared. The initial velocity is 40. We're throwing it up, so it's going to be positive. So plus 40 t. And the initial height is 100. So plus 100. So there is our position equation. All right, I'm going to skip ahead to C, and because it says what's the velocity equation. So when it says find the velocity times t, just means what's the velocity equation, which means I take the derivative of the position, which is negative 32t plus 40. All right. Now for this one, find the velocity between t equals 1 and 3. So we're basically, when it gives you 2 times like this, we're finding the average velocity, which is the average rate of change, which means we're using that old school slope formula. So we put the times on the bottom and we plug these into our original equation, which is going to be our position equation. So we plug 3 into the position equation and we plug in 1 into the position equation. When I plug in 3, you plug in 3, you subtract it from 1, all over 2, you plug that into your calculator, and you get an answer of negative 24. All right, so you plug in 3, you plug in 1, subtract them, then you divide by 2, and you get negative 24 feet per second. Remember, I don't really care about the units. All right, find the maximum height of the ball. You set the velocity equal to 0. So 0 equals negative 32t plus 40. 32t equals 40. Divide by 32. I get t equals 1.25 because 40 over 32 is 5/4. So 1.25 seconds. That is the time when it reaches the maximum height. So to get the actual maximum height, you could then plug in 1.25 into the position equation, and that gives you 125 feet if you plug that in. Now, you could also graph this equation in your calculator, and if you find the vertex, the x coordinate you would notice be 1.25, your y would be 125. The x is the time it reaches the maximum height. The y is your maximum height. I don't care which one you use. All right. When does the object hit the ground? All right. So you set the position equal to 0. Plus 40t plus 100. You then plug that into your calculator. Menu 333, and you get 4.045 seconds. That's when it hit the ground. Find the velocity on impact. Well, you're just going to take the answer we found here, E and E, 4.045, sorry, and plug that into the velocity equation, and you get an answer. Remember, all this, just use your calculator. Negative 89.44 feet per second. All right, and that is your answer. All right, so like the last two problems here are both rates of change problems, if I remember correctly. All right, so for number 6, a business is prospering in such a way that this equation represents its total cumulative profit after t years in dollars. How much did the business make during the third year? That is between t equals 2 and t equals 3. So this is the average rate of change, which means we old school slope, but the time's on the bottom. Then you're going to plug those same times into your original equation. We're going to plug in 3, and we're going to plug in 2. All right. So when we plug in 3, all right, 3 squared is 9. 9 times 1,000, it's going to be what? 9,000. P of 2 to 4, that's 4,000. 3 minus 2 is 1. So you end up with $5,000. Now, on any sort of assessment, you don't have to show the step. You just have to show this, and then you could write your answer of 5,000. So $5,000. How fast is the profit increasing at t equals 2? So that is the derivative. So you got to find the derivative of P of t. So I bring the 2 out front, and I get 2,000 t. I just plug in 2. So I plug in 2, and I get 2 times 2,000 is 4,000. So it makes 4,000. It makes 4,000. The profit is increasing at 4,000 a year at the second year. All right. Then 8. A city was hit by an Asian flu epidemic. Now, this is kind of fitting. Officials estimate that T days after the beginning of the epidemic, the number of people sick with the flu is given by this equation right here. So this is the number of people that are sick at T equals a certain amount of days. Provide that T is less than 40 days. At what rate is the flu spreading at T equals 10, 20, and 30? So since it says at specific times, you have to figure out that this is instantaneous, so you figure out the derivative, which is 240t minus 6t squared. All right, so then what you're going to do is just plug in 10, 20, and 40 into those into this equation. When you plug in 10, you happen to get an answer of 1,800 people. At 20, you get 2,400. And when you plug in 40, you get 0, which means it stops spreading. All right, so since it was instantaneous, that's why you plugged into the derivative. All right. Hope if whatever doesn't make sense, we'll go over in class tomorrow and ask questions on it. But hopefully this will give you something to look back on. And if you have any questions, you can always look at this. All right. Thanks.